Now that we know how to find the slope of a line and what the different slopes are, we're going to look at what's called slope-intercept form. Slope-intercept form is an equation that all linear equations are written in. Linear just means it's a straight line. The slope-intercept form equation is y equals mx plus b. We have four variables in here. We're going to talk about what those mean. We know what m is. That's from our previous video. M is the slope of the line. B is a new variable. B is the y-intercept, or where the line crosses the y-axis. So that's kind of where where the line is going to intersect, or where the line goes through the y-intercept. Remember, the y-intercept, the y-axis is the up and down axis. So where does this equation come from? Why do we use y equals mx plus b? Well, we know we have to have 2 points to find slope. So one of our points, just to find the general formula, we could say one point is xy. So it's on the line, it has an x coordinate, it has a y coordinate, and the other point is going to be our y-intercept. Well, let's think about this for a second. At the y-intercept, that x coordinate is going to be 0. Why is that? Well, if we go to plot the point, we start at the origin, right? And we go right or left before we go up or down. Well, if I don't go right or left at all, then I stay on the y-axis and I go up or down according to what the y-coordinate says. So my y-intercept is always going to have an x-coordinate of 0. And since b is our variable for the y-intercept, we'll call that point 0b. Now let's look over here and let's figure out why this equation is what it is. So if one of our points is xy and one of our points is 0b, we can use our slope formula to figure out, or to get, the slope-intercept form. So I say m equals y2 minus y1 over x2 minus x1. That's our slope formula from the previous video. Now I can plug in my points. So I could say this equals y2 is the point y, y1 was b, so y minus b, over x2 was x, and x1 is 0. Okay, so now my equation says m equals y minus b over x minus 0. Well, what is x minus 0? Well, that's just x, right? So now I have m equals y minus b over x. Well, if y minus b is being divided by x, how would I move x to the other side? Well, I have to do the opposite operation. So I have to multiply both sides by x. So now my equation would say x times m, which I could say is xm or mx. So I'll say mx equals, now over here, these x's are going to cancel out. So mx equals y minus b. Now how do I move b to the other side? Well, I would do the opposite of subtract b, so I would add b to both sides. So if I did that, those b's would cancel. So now this would say mx plus b equals y. And I could rewrite that the other way and say y equals mx plus b. So that is where this equation comes from. The equation is the general form of a straight line that has a y-intercept at b, m is the slope, and xy is a point that falls on that line. Now let's look at some example equations here, and we're just going to find the slope and the y-intercept. So we'll zoom in here and look. So you're going to be surprised at how easy this is. All I'm doing is I look at my equation, and this is y equals mx plus b. Well, if m is the slope and b is the y-intercept, all I have to do is look here. So my slope is 2, and my y-intercept is 3. That's all I have to do. This one, my slope would be 2 over 5, and my y-intercept, be careful here, would be -7. Okay, because that subtraction sign would go with the 7. Now this one looks a little different. I can tell what my slope is. My slope is 4. But there's nothing being added or subtracted here. So how do I know what my y-intercept would be? Well, if I wrote plus 0, would that change? No, it wouldn't. So my y-intercept is going to be 0. That means this graph is going to go through the origin. Remember, the origin is the point 0, 0. So we could say that this is a proportionate or a proportional graph. Okay, let's look up here. What do we notice? Well, it's supposed to be y equals mx plus b, but our slope is on the left side. So we're going to have to move 8x to the other side of the equal sign. And to do that, I have to do the opposite operation. But right now, 8x is positive. So I would need to subtract 8x from the left side and subtract 8x from the right side. Well, positive 8x and negative 8x are going to cancel. So now this equation says y equals 4 minus 8x, but I'm going to write it mx plus b. So negative 8x plus 4. Now it's easier for me to see what my slope and y-intercept are. So m would be negative 8, so my slope is negative 8, and b, or my y-intercept, would be 4. And the last example. Now this one really, some stuff are really out of place, right? My slope's on the wrong side, and I don't have y, I have 3y. So here's how we would do this. Same kind of thing, I would add 2x to both sides. So that 2x and the negative 2x would cancel out. And I would have 3y equals 2x plus 12. I don't want 3y, I just want y. So to do that, I'm going to have to divide by 3. Whatever I do to one, I have to do to all of my terms. So I divide all 3 of those by 3. So these 3's will cancel, so that will become y equals. Now remember my slope, one of the ways to find slope is rise over run. So let's just leave that as 2 over 3. So let's say y equals 2/3 x plus, now what's 12 divided by 3? Well, 12 divided by 3 is 4. So now I could say that my slope is 2/3 and b, or my y-intercept, is 4. So this is how we would find slope and y-intercept from the slope-intercept form equation. Now let's look at a couple of special equations. We talked about this a little bit in the previous video when we mentioned the sign in my classroom, Hoy Vux. So what happens if you don't have an x or a y? So for example, if they told you the equation of the line is just y equals 4, not y equals 4x, just y equals 4. So there is no x. So where's my slope? Well, there is no slope. Okay, I didn't say there's an undefined slope. I said there is no slope. So that would mean my slope is 0. So this would be a horizontal line. There's no uphill, there's no downhill. It's a 0 slope. And my y-intercept is what my y is equal to. So my y-intercept would be 4. So this would be a horizontal line through the y-axis at the point positive 4. All right. Our other special equation, if I had x equals negative 8, or x equals a number, okay? So I'm looking here, and since I have x equals negative 8, that means it's going to go through negative 8 on the x-axis. But if I look at this, there's no y in my equation, so it's never going to cross the y-axis. So if it is x is equal to negative 8, then it's going to be an undefined slope, because that would be just a vertical line through negative 8 on the x-axis. So if it doesn't ever cross the y-intercept, I do not have a y-intercept. So my y-intercept is not 0. My y-intercept, I could say, it is not applicable. There is no y-intercept because it never crosses the y-axis. So those are a couple we have to be careful with. So we could remember Hoy Vux. So if I have y equals a number, then it's going to be a 0 slope, and my line will be horizontal. If I have x equals a number, my slope will be undefined, and my line will be a vertical line. So now let's take a look at a graph, and let's see how we would graph equations that are in slope-intercept form. Okay, so we're going to do 3. We have one that says y equals 6x plus 3, one that says y equals negative 4x minus 8, and one that is just y equals 3x. So remember, our equation is y equals mx plus b. Here's kind of how I like to remember where to start and how to plot points. I'm going to begin with b, and I'm going to move with m. So let me show you what I mean. Let's look at the first equation, y equals 6x plus 3. What is my b? What's the y-intercept? Well, the b is 3. So I'm going to begin at 3 on the y-axis. So if I look at my graph, here's my origin. So I'm going to go up 1, 2, 3, and I'm going to plot a point right there. How do I know that point's there? Because my equation says that this line, or this graph, is going to cross the y-axis at the point positive 3. So I know that the graph, or I know that that point is on the graph. And now, so I begin with b, and now I move from my y-intercept according to my slope. So if my slope is 6, that would be like 6 over 1, right? So I'm going to rise, or go up 6, 1, 2, 3, 4, 5, 6, and I'm going to go right 1, and I'm going to put a point there. I can do that again. 1, 2, 3, 4, 5, 6, right 1. So if I go up and right, those are both positive, so my slope is positive. I could also go down and left, because that'd be a negative over a negative. So I could go down 1, 2, 3, 4, 5, 6, left 1. Okay? So now what I'm going to do is I have my 4 points. So I'm going to take my ruler or my straight edge, and I try and line up my points the best that I can. And I'm going to take my pen or my pencil, and I'm going to connect my points. Hopefully a little bit better than that, but I'm going to connect my points, and there's my line. There's my graph. So I'll zoom out a little bit here and show you that. So now once we do this, we can take our equation, y equals 6x plus 3, and we can write that next to it, just so we know which line that was. Y equals 6x plus 3. So we've done that one. Okay, let's look at the next one. The next one says y equals negative 4x minus 8. So remember, begin with b, move with m. So we begin at negative 8. Okay, so let's start at our origin. Let's go down 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to begin right here. There's my first point. Now my slope is negative 4. So I know that my graph, when I get done, needs to be going downhill. So think about rise over run. If I go down 4, that's a negative 4. So if I go left 1, that would be a negative over a negative, which would be positive. So I need to go down 4 and right 1. So 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. Now if I go down and right, I could also go up and left. So I go up 1, 2, 3, 4, left 1. 1, 2, 3, 4, left 1. So now I take my straight edge or my ruler, and I connect my points. So kind of what I like to do to help my graph be as accurate as possible is get 2 points on each side of my y-intercept. Okay, so I had 2 here and 2 here. Now I see that my line is going downhill, so that corresponds to my negative slope. So that's kind of a way I could check myself there. So now I could write my equation right here, y equals negative 4x minus 8, just so I know what line that is, if I do more than one on a graph. All right, and the last one, so we've done that one. Y equals 3x. Well, wait a minute, there's no b, so where am I going to begin? Well, like on the equations we looked at on the first sheet, if I don't have anything here, if I don't have a y-intercept, then that means I'm going to start at the origin, or my y-intercept will be 0. So I could put a point right here on the origin, and now I look at my slope. My slope is 3, so that'd be like 3 over 1. So I'm going to rise 3, so 1, 2, 3, and I'm going to go right 1. 1, 2, 3, 1. Now also I could go down 1, 2, 3, and left 1. 1, 2, 3, left 1. So now I take my ruler, have my 5 points, and try and line them up the best that I can, and I draw my line through. Now I can take my equation and write it next to my line. That way I know which equation goes with which line. So we've looked at how to graph using slope-intercept form. We've looked at some special equations when we have y equals a number or x equals a number. And we talked about what the slope-intercept form of a line is. We talked about where the slope-intercept form of a line comes from. And we used some examples to find the slope and the y-intercept.